Okay, we're starting our first day of Trig. Day one is just basic stuff that I'm expecting you to master because we build on this. So a lot of what we're coming up is building off of these ideas. Okay, a lot of people think that Trig is the hardest part of Precalculus. I'm sure you've heard that. Is that fake news? Is that
news?
It's okay. You said fake news. Everyone else is shaking their head, and you're just saying fake news because I said it. Everyone wants to say the word fake news. Yeah, see, people start like, yeah, fake news. So I'm here to tell you that I think Trig is actually one of the easier concepts. You just have to actually work at knowing what's going on, and once you do that, you're good. Okay? A lot of people think I have to memorize a lot of things in Trig. I disagree with that. I personally only memorize like 3 things from Trig, and that's it. And I can apply it from there. And that's not like, oh, you're a teacher, whatever. I did that in high school too, and I was learning Trig in 10th grade. I just applied everything. It wasn't 10th? I was in New York State. We learned it earlier. New York State people learn things earlier, and then some things later. Like we did Trig in algebra too. So I'm gonna go through this. I'm gonna happily explain why some things are the way they are, if need be. Some things are just things you just need to memorize. Like the first couple things are just the ratios. Like what's the sine ratio, the cosine ratio, the tangent ratio. So let's start with that real quick. And you've seen this before. And I'm sure teachers are just like, oh, STOCHATOA, and I'm like, okay, cool, I'll just memorize that. But sure. So if that is theta right here, next to it is, what word do we use in math? Let's say something's next to it. Adjacent. Oh, no, I need to spell it correct now. I think that's correct. Because it's next to it. But Coach Meinbauer, this one's next to it too. Well, I agree, but that one is special. Why is this one special? It's the hypotenuse. Oh boy. Oh boy.
I just spelled it wrong. It's okay.
No, I gotta spell it. O-T? U-S-E? Somebody Google this for me. It's O-N? That's fake news. It's correct? Okay, cool. Alright. And then the last side is the opposite of the theta, so we call it opposite. Uh-oh. Maybe it's opposite, or opposite, or opposite, or opposite. I don't know. Okay? And then what if I had theta over here? Okay, so opposite and adjacent flip-flop. So this would be adjacent right there. Opposite right there. And hypotenuse right there. I don't know. A lot of things in English we don't say. What's that? Huh? Yeah, I feel the same way. Okay, so what's the ratio for sine? And you have to use these words. And ratio, by the way, means division. Ratio is division. I don't want to use these big words. Granted, I just used a bigger word to describe a smaller word, but ratio means division. So what is the sine ratio? What about cosine? Okay, any confusion there? I'll just use SOHCAHTOA to remember it. That's what I do too. I learned it back in whatever grade I lied about. 10th grade, I said? Okay, I'm just going to stick with that. Actually, I really might have learned it in elementary, middle school. I think we, like, dabbled in it in middle school. Did you dabble in it in middle school?
I think we dabbled in it in 8th grade.
Alright.
And if you were not, yeah. I swear.
So, have you heard of cosecant before?
No. Yeah, we did. It actually sounds familiar.
Okay, so I'm assuming, so when you do trig in geometry, it doesn't do these are reciprocal identities. Reciprocal means, I don't want to say the word opposite because we already have that, but sure, we'll say flip-flop. You flip-flop the ratio. So cosecant and sine are related. They're just reciprocal identities of each other. So cosecant would be secant and cosine are reciprocal identities of each other. So this would be and cotangent and tangent are reciprocal identities. So this would be alright, so this one's kind of like harder to do, like the SOHCAHTOA. This would be like Cho-sha Kawa. No, Ka-o. Cho-sha. No, sha. It's A, not O. So it's Cho-sha Ka-o. Ka-o. Or you can just realize that these are just identities. So every single identity has a co, by the way. Every single reciprocal identity has a co. So sine has a co, secant. Cosine has a secant, and tangent has a cotangent. All right, each set has one co. You can't double up the co. A lot of people think that cosecant and cosine are related. They're not at all. So each pair has one co. All right. So let's go through here. So there's another theorem that you've heard of before that's going to help me fill out the missing side here. Yeah, it's Pythagoras' theorem. It's the Pythagorean theorem. Okay, so it's side squared plus other side squared equals hypotenuse squared. That's one way to think of it. Or you could say adjacent squared plus opposite squared equals hypotenuse squared. It's not going to matter. Just as long as the hypotenuse is the c squared, you're good to go. So how can I find this missing piece right here? Do math. Very good. That's how I'm teaching you from now on. All right, how do you do this problem? Yep, do math. Okay, let's move on. So 2 squared plus b squared equals 4 squared. What is 2 squared? Yeah, why is it not plus or minus, by the way? Yeah, because this is talking about whenever you use Pythagoras' theorem, it talks about geometry. It's measuring lengths. You can't have negative lengths. So can I reduce this at all? Is there a perfect square that comes out of 12? 4? So it's root 4, root 3, which is really 2 root 3. Okay, so for those of you who don't know, so root 12, what perfect square comes out of 12? A root 4, and what's left? A root 3. I'm just breaking it down. Root 4 turns into a 2 root 3. That's it. That's math.
I know I just helped all you by saying that.
Okay, so there's 3 types of equations to solve. So first off, a lot of stuff we do today is going to be in degree mode because it's applicable stuff. I'm not a fan of degree mode, but it's whenever you have word problems, it's typically in degree mode. Otherwise, it will be in radian mode, which I'll talk more about next class. So 3 types of equations to solve. So if we're doing word problems, you're going to have it where your unknown will be on top. So, what's that? Okay. So how would I solve for x in this equation? You don't need to actually do this out. I'm just showing you. So it's going to be times 5 equals x. So that's how you solve for x there. What this one? How do you solve for x here? Kind of, yeah. It's actually a two-stepper. Yeah, that's a lot of work. Let's not do that. I know what you're saying. Multiply it by x, and then divide by... So this x, I'm finding a length here. Okay? This one, I'm finding an angle. Right? I don't know if you've heard this one before. I'm just going to tell you what it is. This would be arc sine or inverse sine of 3/5 equals x. We won't really tackle that till a little bit later, but I'm just kind of showing you how to do it. So, someone said that's a really, really small angle. Do you even know what inverse sine of 3/5 is? My guess is you're in radian mode.
36.87.
Yeah, it was about 30, so it's 36. All right. So, whenever you have a question that says solve the triangle, it means you need to give out every piece of information that you can possibly give about it, which is I need 3 angles and 3 lengths. Okay? So, it says solve the right triangle. So, obviously this is where the right triangle is. That's 90 degrees. So I'm going to call this C. And then from there, it doesn't matter which one you call which. So I'm going to call this one angle A. I'm going to call this one angle B. It does not matter because our pictures never really to scale. I use angles as big letters. Capital letters. Okay. I use the sides as lowercase because when you do Pythagoras' theorem, he always uses lower cases because that's length. Those are sides. So it's always the opposite side. So little b would be located the opposite of angle B. Little a is located, and little c is going to be the hypotenuse in this case, which I think all these problems do that anyway. So, okay, so let's go ahead and solve for it. So I know angle A. What is angle A? That's pretty nice. And this is 90. Is there a way I can figure out angle B? They should all equal 180 degrees. So am I using any trig? I am not using any trig here. We're just doing math. So what do you get for angle B? What is it? 55.8 degrees. Because that plus that plus that equals 180. Are we cool so far? Okay. I do have the B value, which is 19.4. All I need is one of these, and then I can find the other one by using the Pythagorean theorem. So, which one do you think I should solve so I can use the Pythagorean theorem? Let's solve A. It's a little bit easier. But wait, how can I find A? Magic. So, I have this information. I have A and B. I don't really care. I usually use what's given to me. It's not going to matter. So, I need to relate A to one of these guys. Which one should I relate A to? I should relate it to B. Why do I relate it to B? Because I know stuff about B. Why would I relate it to C? You're going to have a bad time that way. So I have angle A, I have little a, and I have little b. What trig function can I use so I can relate all of these together into one ratio? Tangent. Because if you use tangent, you get A, which is opposite, and you get B, which is adjacent. So tangent of 34.2 degrees is equal to A.
I have a question.
Yeah, go for it.
How do I know which one's adjacent and opposite? Like, did you point out which one was where the thing was?
Yeah, because I'm using angle A right here.
Okay, so whichever one we use.
Now, could I have used angle B?
Yeah.
What would it look like if I used angle B? I'll go in a different color, blue. What would it look like for angle B? It would be B over A. You would do tangent of 55.8 degrees equals B, which is 19.4 over A. It doesn't matter.
Oh, that makes sense.
Same thing. But I like this one better. Why do I like the top one better than the blue one? Less moving parts, happier I am. So, what you need to do is go into your handy-dandy calculator. Your calculator at the top will tell you what mode you're in. Right there, it says radian mode. So if you go to mode, you can go ahead and flip this little guy over to degree mode. Now, I usually don't do this, by the way. I don't. I try to outsmart things because I hate this mistake of, I forgot to put it in degree mode. I hate that. So I try to eliminate that option. I'm going to tell you how to eliminate that option. But we'll put it in degree mode for right now, and then that'll just be our fail-safe. So for these problems right now, because we're using geometry, we're asking for angles, I want degree mode. Okay? So, how do I solve for A here? So 19.4 times tangent 34.2 degrees, and that's going to give me my A value. So this is what I do. I do my 19.4, and tangent, by the way, right smack dab in the middle of your calculator, is sine, cosine, tangent. So I'm going to use tangent. I know these lights are in the way. So I'm going to use 34.2. The fail-safe. If you go to, I'm trying to remember now because I'm just doing this. Angle right there. So you go to second apps is an angle. You can actually just type in a degree right there and not even worry about what mode you're in. It's beating the system. So it's second apps. We'll pull up the angle symbol for you. Just trying to beat the system here because I would hate it for, oh my gosh, I got half my test wrong because I was in the wrong mode. Well, this is going to help you out. So I get an answer of? Now, hey, I'm curious. Does it matter what mode I'm in? What if I go to radian mode and I do the exact same thing? Same thing. Mode does not matter when I put the angle in. So I highly suggest you put the degree in. I suggest it. I've been teaching trig stuff for many, many years, and I've seen many, many tears in my life of, I was in the wrong mode the whole time. Well, did you do it my way or your way? Do it my way, and you beat the system more than half the time. There are times where you need to be in the correct mode, but this is not one of them. Okay? So A is equal to, always round to the nearest thousandths. And then how do you find C? So you're going to do this 13 point, I'm going to put dot, dot, dot. That means I'm going to type in that entire thing. Because if you type in 184 instead of the entire thing, you're going to get a different answer. You're going to have a bad time. Okay? Plus B squared, which is 19.4 all squared, equals C squared. Okay? So take that number, go up, hit enter. It recalls it. So go up, and hit enter, and it'll recall it. Square it. Plus 19.4 all squared gives you my C squared value. This is what C squared equals to. I'm going to just do 550 dot 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 equals C squared. So what do I do to find the value? So second square gives you square root, and just go up, recall it, and hit enter, and kablamo, your C value is 23.456. That works, whatever. You can truncate it. I'm not going to care. So did I solve my entire triangle? Yeah. I'm kind of taking a long time on this because I want to hit this home. This has got to be slam dunk from all of you. You have to understand how to do this. Okay. Questions? I'm going to go do the next problem different color because they don't overlap a little bit. Let's use purple. Alright, number 3. Read through it. Tell me what's different about this one than the last question. We have 2 sides and 1 angle. So that's C. Let's just stick with the same thing. This is little a, which is 25. This is little c, which is 35. So this is big A, and this is big B, and this is little b. What's the easiest one to figure out right now? How do I figure out B? 25 squared plus b squared equals c squared, which is 35 squared, right? A squared plus b squared equals c squared. So b squared is going to be equal to whatever 35, keep writing 2, 35 squared minus 25 squared is. I believe this could be a triple. It's not a triple? Yeah, no, it's not triple. It's all. It looks like it might be triple. It's not. So 25 squared. So 35 squared. So it's 600. So b squared is equal to. Everybody's giving different numbers to me?
No, I got that.
Okay, somebody said they got 44. Hey, let's look at this. Your hypotenuse is your longest side. You got 44, you're going to have a bad time. I'm assuming you added. So B is equal to 24.494. Okay? I need to find these 2 angles. My advice here. Use what's given to you to find the first angle. So I have A and C given to me. So which one do you want to find first? I don't care, A or B.
A.
Sure, let's find A. What's the relationship I can make with A and C? Opposite hypotenuse, which is? Sine of A is equal to? So to find an angle, this is where you're going to use this little sign to the -1. Now this one, it has to be in degree mode. There's no way to manipulate it as much as I would love to. So this one has to be in degree mode. So am I in degree mode right now? How do you know I'm not in degree mode? Says it. So just go to mode. Make sure you change it. Okay. So we're going to do second sine is going to spit out this inverse sign. And then you type in 25 over 35. And you get about 45 degree-ish. It's a great question. If you did cosine of the same numbers, what would that find? It would find angle B. It's great. Just make sure you put it in the right spot.
Great. Okay.
So 45.585, right? How would you want to find B now? You could do by doing... I prefer to do trig once if I can. Let's go ahead and do the 180 plus 90. 90 plus A plus what gives you angle B. So what I'm going to do is I'm going to do 180 minus the angles I have. I have 90 and then I have this guy right up here. I recall it. So angle B is equal to Alright, any questions on this? I'm going to go through these word problems kind of quickly because we just did all of the hard work here. Word problems, a lot of you think that they could be difficult because I'm assuming you've been taught in a way where teachers make them difficult. I'm going to try to make it as easy as possible. It says angle of depression versus angle of elevation. They are the exact same thing. Did you know that? They are all right here. This is the angle of depression and the angle of elevation. Sure, I'll show you why. Because so right here is the angle of depression, right? Here's elevation because you're looking up to see the elevation. This is depression. Why are purple and tan the same? They're opposite. We're not doing proofs, we're just...
I know, but that just reminds me of proof.
They're opposite adjacent, so purple angle always wins. Purple angle always wins. So every time I have a word problem, I draw this exact same triangle. I don't draw anything else. Purple always wins. So, for number 4, a 12-meter flagpole casts a 12-meter shadow. Find the angle of elevation. I'm going to draw this exact same triangle, and I just need to figure out what goes on. I hate all of you. Alright, so what can I start labeling? The sides are each 12, because this is the flagpole right here, and this is the shadow right here. As for the angle of elevation, which angle is it? It's always that one. Okay? I'm going to call this theta, by the way. Anytime I don't know the angle, I'm just going to call it theta, if it doesn't already label it for me. So, how can I find theta? I have to relate it to the sides, which are opposite and adjacent. Actually, you can mess this one up and be fine. So, tangent of theta equals 12 over 12. Well, what is 12 over 12? 1. Same thing. Okay, so we type in our calculator, you're going to get 45 degrees. Do I need to show you typing it in?
No.
How do you know it's 45 degrees before you even typed it in? Because every right isosceles triangle, so the side lengths are the same. So it gives you 45 degree angles, correct? So theta is equal to 45 degrees. You could have used your calculator, but this is easily a non-calculator problem. You had to think through it a little bit. This is why I love Trig. You have to think. Love Trig. Do you really?
Yeah, I do.
Hey, don't be saying this stuff and not meaning it.
No, I love triangles.
That makes me excited. Alright, we're sitting here just a bunch of word problems. I'll do this one. I might just look ahead, see if I need to do another one. They're all the same. So let's go through this. So a biologist wants to know the width of a river in order to properly set instruments for studying the pollutants in the water from point A. The biologist walked downstream 70 feet and sights point C. From the sighting, it is determined that the angle of elevation is 45 degrees. I know there's a hole punched through it, but it says elevation. How wide is the river? So what do I know?
You know the angle of the elevation
Where the heck is the stream in this question?
It's the line of A, left and right.
Left and right?
Yeah.
It says from A, he walks downstream.
He walks downstream, A to the right, and then he sights back to, he looks back at the along the hypotenuse.
Oh. the hypotenuse. He goes, this is stupid and there's any questions like this on the test.
I don't make the test.
You need to start making the test.
They're already made, so why would I make them?
Already made.
Usually.
So you told me to give it last year.
I don't know. Mr. Benschneider, he says, "Oh, I'll do something with whatever test," and then it just happens to be made. So he makes them. They're not last year's because we're doing it. We're in 9 weeks now. This is different. We combine different things. They're not last year's.
You got an A?
Okay. From the sighting, it is determined that the angle of elevation is 54 degrees. So this is 54 degrees. How wide is the river? So I'm looking for my blob. Okay, so how do I find blob? Why am I using tangent? So tangent of 54 degrees is equal to blob over 70. So 70 times tangent of 54 degrees gives me an answer of, somebody just tell me what it is.
96.347.
It's a word problem. You need more.
B. Duh. What is the other thing?
So, hey, last questions here. We have a ramp, we have a ladder, we have a church, steeple, and we have a plane. Which one of those are we going to do? Plane? Plane? Plane. Alright, so from the time a small 100 feet high and 1,600 feet from its landing runway, the plane descends in a straight line to the runway. Determine the plane's angle of descent. So here's the same triangle I draw every single time. Let's label it. What can we label? 100 feet off the ground, which would be the up and down one. Yeah, ground feet means it's on the ground. Where's the angle of descent located? It's always the same thing. So I'm going to call that theta. What relationship can I make? The good one. Someone just said, why is the answer so small? Why is it small? This is not to scale. Can I draw this somewhat to scale? Like, I try to draw 16 segments that were the same length as that. So is this a really? No, let me go ahead and try to connect this nicely. Not very good drawing, so that's the best I can do. So is this angle very big or very small? It's tiny. All right. So when I type this in my calculator, I'm going to do inverse tangent of 100 over 1600. What do I get? 76 what?
76 degrees.
So we had this like fun activity that you could do, like it's like a NASA, NASA. I want to go to the Bahamas. It's like a nice little nifty NASA thing where it's kind of like the same type of questions as this, but they're like, it's going at a rate of like 100 feet per second, and then they give you time to figure out how high things are at certain times. Let's not do that. I'll be sure on time because we don't run over your test more, so.